Neural radiance fields, or NeRFs, are an emerging field in graphics with the potential to offer new forms of visual effects, allowing for photorealistic renderings of objects and environments. NeRFs use machine learning to render new views of a scene, trained by an input of images or a video of the object or environment. Nerfstudio is an open-source framework for training and rendering NeRFs. This tutorial is on the Nerfstudio Blender Visual Effects add-on, which can allow for generating Nerfstudio camera paths to render NeRFs, allowing for more controlled camera trajectories, compositing Blender meshes and renders over NeRFs, and also compositing multiple NeRFs in a single scene. For installing Nerfstudio, please follow the instructions on the Nerfstudio documentation site, and if you have any questions or issues while installing, feel free to ask on the Nerfstudio Discord channel. I will first show compositing a Blender render over a NeRF render, then also show compositing multiple NeRFs in a scene. For additional information, you can refer to the Blender VFX Add-on documentation page. Essentially, we composite the Blender render over the Nerfstudio renderer, using the Nerfstudio camera path generated by the Blender add-on. We would first export a mesh or point cloud representation of the NeRF from Nerfstudio and import it into our Blender scene. Once we have the NeRF representation in our Blender scene, we can then use the Blender add-on to generate the JSON file. And with this exported JSON camera path, we can use Nerfstudio to render it. Finally, we can render out our final render by compositing the Blender render over the NeRF render. To download the Nerfstudio Blender VFX plugin, we'll first go to the Nerfstudio repo on GitHub, and then go into the scripts folder, and under the Blender folder. This nerfstudio_blender.py is the file that we want. So to download this, we'll right-click on the raw button and click Save Link As, and then click Save. And this should download the Python file. Now let's import our Blender script. So I've opened a new scene in Blender, and you can go into Edit, under Preferences, and select Add-ons, and we'll click Install. And we can navigate to our directory and select the Nerfstudio Blender add-on. And you can see over here that now I've enabled it. And now if I close this and go into my render properties, it should be visible over here. We'll first start out by exporting a point cloud or a mesh representation of the scene. In this case, for this courtyard environment, I'll be exporting a point cloud. For larger and more complicated environments, I would recommend using a point cloud instead of mesh because the meshing is not as accurate for really large scenes. In this case, I'm going to also first go to the export point cloud, and I'm going to specify the center and the scale for my crop. I can also go into controls and click on crop viewport and accordingly adjust the scale. And since this is just going to be used as a reference within Blender, all we need is just some key landmarks in the environment so we know how to place the objects. So I think that this is a good enough representation of the NeRF. And I'm going to only copy these values into the export. So now I have the command over here to essentially export this point cloud. Now you can export the NeRF as a .ply point cloud file. You can also refer to the documentation for additional instructions. You can use the command ns export point cloud help to find the command line arguments for generating the point cloud. Now I've imported my point cloud into the scene, and I'm going to accordingly edit and scale it. And sometimes you also need to rotate the export because it might be aligned off center. As you can see, you can notice that this resembles the original NeRF. However, working with point clouds could also get a bit tricky because it's not a mesh representation and it's a bit harder to view. So what you could use is you can go to the geometry nodes and you can add a node, mesh to points, and this would kind of add some geometry around the point cloud, and I'll just reduce it to be a smaller amount. And here it's a bit clearer to see everything. We don't really need to worry about the materials because this is just used as a reference. Now I'm going to place my mesh over here and scale it accordingly in the scene. Since I would also like to have some sort of lighting effects represented on top of the mesh, I can add a shadow catcher. So when I have my virtual light in the Blender scene, it would be able to cast the shadow of this mesh onto the NeRF. So to do that, I'll create a new plane. And I'll make this plane at the same elevation as the ground. And I'll have to change the render engine to cycles under the render properties. And still, while I've selected the ground plane, I'm going to go into the object properties and I'm going to select shadow catcher under the visibility panel. This will make the ground plane not render as a mesh, but it will only render the shadows that are cast on it. I created a short camera animation for this example, and I also have the ability to animate the focal length throughout the animation, which will also be sent over through the camera path. I can also animate the NeRF background if I want to, as well as position, rotate it, and scale it. Now before we render, we need to also make sure that the point cloud representation we have is hidden in the final render. By selecting this render icon over here. And we also need to make sure that our background is transparent. So under the render properties, select film and select transparent. So when we render this frame, we should only see the mesh and the shadow from the shadow catcher. Once we're ready to render, you can specify the resolution. You can also specify the percentage and the frame rate, as well as the frame start, end, and step. And all of those components are also accounted for once you're rendering the NeRF in the Nerfstudio renderer. When we're going to render the Blender frames, we have to also make sure that we export as a PNG and with an alpha channel, because we're going to have a transparent background, because we're going to be layering this Blender render over the Nerfstudio renderer. Now, once we have everything ready to render the NeRF, we can go to the Nerfstudio plugin by going into Render Properties, scrolling down to the Nerfstudio Add-on, and over here we can select the NeRF representation in our scene. In this case, it's the point cloud representation. So we can select that with the eyedropper tool, and now we're going to generate the JSON camera path file. Under camera path for Nerfstudio, you can also select the file output. In this case, it will be writing the file in the same directory as our Blender file. So once we click Generate JSON file, it will run through each of the frames and generate a camera path that we can input into Nerfstudio for rendering. We can see over here that the camera path has saved as camera path blender.json. Once we have the camera path ready, we can now render it in Nerfstudio. You can get the command line arguments using the command nsrender help. Once we have our final NeRF render from Nerfstudio, I recommend separating it into multiple frames from the given MP4 file. We can do that also within Blender by creating a video editing file. And what we can do is we can place our MP4 file over here and essentially render out every frame as a PNG. We should also make sure that our frames start and end correspond to the camera clip that we've given. In this case, it's 120 frames. We can now import our renders into a video editing software. In this case, I'm using Premiere, and I'm going to be selecting image sequence. So in this case, I'll be importing my entire render from Nerfstudio. And we'll also import the render from Blender, also as an image sequence. And now, as you can see, once we've layered the two layers on renders, you can see that they're properly aligned in space. I'm going to first export a NeRF representation of this background NeRF, and I'll do this by exporting a point cloud, similar to the previous part, where I would use the nsexport point cloud command. You can also export the background as a mesh instead of a point cloud. Either way would work, but generally for large environments, a point cloud is recommended. Now for a bear statue NeRF, we want to crop it so we only have the statue. So first, once I have the NeRF open in the editor, we'll click on the crop viewport checkbox. This will crop our NeRF. However, we also need to make sure that we scale and center our NeRF accordingly so that our NeRF only has the statue or object of interest in the NeRF. You can adjust the scale and center of the crop box. So in this case, I would be adjusting these parameters to make sure that only the object that we want in the NeRF to be rendered will be in our final render. Next, we want to keep note of our scale and center values for our crop so we can make sure that we keep those values in when we do the final render. To do this, I'll create a basic camera path. So that we can download the camera path. And this JSON file will contain the values that we have for our center and our scale components of the crop. And we will be using that once we generate the final camera path. Next, let's export our mesh. In this case, I'll be choosing to export it as a mesh instead of a point cloud, but either way would work. I'm going to change this to TSDF. And I'm going to also make sure to re-enter the same values of our center and scale for the crop. Now that I've entered the center and scale values for the export crop, I'm going to copy this command over here, and I'm going to run it to export the mesh. I've created a new Blender scene where I've imported the point cloud of this courtyard. I've also created a plane to act as a shadow catcher, which you can select by going to Object Properties and selecting the shadow catcher. This will act as the ground and also will allow me to cast shadows off my imported composited NeRF over the background NeRF. First, I'm going to import the OBJ file, which I recently exported from Nerfstudio. When I import it, I'll have to reorient it and rescale it to fit in the scene. I created a short animation clip where I animated the camera and I also animated the mesh of the bear. The Nerfstudio plugin will allow me to also animate the translation and rotation and the scale of the NeRF. So in this animation, I make the bear scale and move up, and the NeRF of the mesh of the bear will be composited over the background, which is this courtyard. Because I have a shadow catcher as the plane on the ground, in the render, the shadow of the bear mesh will also be visible, and this will correlate and correspond to where the shadow of the NeRF would be. Now that I'm done with animating my scene, I'm going to start to render the shadow layer. To do that, I'm going to make sure that all the elements in my scene are not going to be visible through the render except that shadow. So in this case, for this courtyard background, I'm going to make sure that it's invisible when I'm doing the render. And another thing is that since I want the shadow of this mesh over here of the bear to still be visible, I don't want to make this, I don't want to disable it in the final render itself. What I'm going to do is I'm going to first make sure I'm in cycles. And I'm going to go into visibility, and under array visibility, I'm going to uncheck mark the camera. And this will actually make it so that when I do the render, it will only show the shadow. I'll also have to make sure that the background will be transparent. So to do this, I'll go into the render properties. I'll go to film and I'll make sure that transparent is checkmarked. Now, if I render this frame, I should only see the shadow visible. Now that I've rendered out the shadow layer, I want to now render out the bear, and I also want to render the background courtyard NeRF. Now I want to create the camera paths for the background courtyard as well as the bear. To render these NeRFs, I'm first going to do them individually. So under the render properties, I'm going to navigate to the Nerfstudio Add-on. And over here, I'm going to use the eyedropper tool to first render the courtyard. So I'm going to select this platform courtyard point cloud over here. And I'm going to select generate JSON file. And it will create a JSON file, camera path blender.json, in the specified file path. And in this case, I have it set up so it will generate it in the same folder as my Blender file. You also need to make sure that you rename your file because every time you click generate JSON file, it will overwrite the previous camera path blender JSON file in the same directory. Next, I'm going to create the camera path for rendering the NeRF of the bear. So I'm going to first deselect the background courtyard and I'm going to select the bear. And similarly, I'm also going to generate the JSON file. To render the background courtyard NeRF, we can follow the steps that we did when we were compositing mesh over a NeRF background, and where we can just directly run this camera path into Nerfstudio to render it. However, since this bear has an additional component where we're cropping it, we also need to make sure to add those additional cropping details within the camera path for the bear. Now that I've opened the JSON file for the bear camera path, I'm going to scroll all the way down. And at the end over here, I'm going to add another component for cropping. Previously, we had exported a camera path from the Nerfstudio viewer just when we were exporting the mesh of the bear. If you scroll down also in this camera path, there's going to be a crop section over here. This has the values of the crop center and scale, which is what we need. So we're going to copy those. We're going to go to the camera path that we generated from Blender, and we're going to add it to the end of the JSON file. So right after the is cycle, you're going to add a comma, and then you're going to paste the crop over here. So this has the components of background color, crop center, and scale. The background color doesn't matter because we'll be removing that. But for the crop center and scale, these will have the same values of the crop export that we had of the bear. Now we will save our camera path, and now we will run this in Nerfstudio to render out the bear and a cropped version of it. Now that we have our camera paths, we can render out the NeRFs. We can first render out the background NeRF. But however, to render the crop bear NeRF, we need to actually render two NeRFs. One is an RGB render and one is for accumulation. The accumulation render will give us a mask so we can remove the background from the RGB render. You can render the accumulation by adding the command line argument, rendered output names, accumulation. You can find the render command using the nsrender --help command. Now I'm going to convert the render into an image sequence so we can properly align each of the render layers frame by frame. I'm going to do that by creating a new video editing file in Blender, and I'm going to be dragging the render file MP4 over here. Next, I'm going to make sure the resolution match along with the frame start and the frame end. So in this case, I'm ending at 100 frames. And I'm going to export either as a JPEG or a PNG. In this case, we don't need an alpha channel, so JPEG will also work. Next, I'm going to repeat the process with the accumulation render, and I'm going to follow the same steps, or I'm going to also create an image sequence from this render. Finally, I'm going to create an image sequence from our NeRF render of the courtyard. Now we're going to composite the layers together in a video editing software. Here I'm using Premiere Pro. We're going to first import the image sequences of the renders. Now I've imported all the individual layers that we'll need to use to construct the final composite. Over here I have the background layer. Next I have the shadow layer. Next I have the render of the NeRF, of the bear, and then here is the accumulation of the bear NeRF. Now what I'm first going to do is leave this background as the bottommost layer, and then on top of it I'm going to place the shadow layer. Next, I'm going to add the RGB of the bear. And finally, I'm going to add the accumulation render. What we want to do is we want this accumulation layer to act as a mask, basically, for the RGB render of the bear. To do that, we can go into the effects panel in Premiere and type in track matte key. This will apply to the RGB bear render. And now once we have that applied, we can select composite using matte luma and select the matte as video 4. So now we've composited all the components of the scene. We have the background, we have the shadow, and we also have the bear. I can also choose to have the NeRF representation as a mesh instead of a point cloud, and the process would be similar, where I would use the Blender add-on to select the NeRF representation and then generate the JSON camera path. You can also add an environment map to your Blender scene by rendering an equirectangular render in Nerfstudio. We can do this in Blender by creating a new camera object, placing it in the area where we want it to be in our scene. In this case, I'm going to have it near our mesh. And then to convert this camera into an equirectangular camera, we're going to go to the camera properties and then select panoramic type and select equirectangular. You have to make sure you're in cycles. Now that we set it up as an equirectangular camera, we're now going to set this as the active camera so that the Nerfstudio plugin will know which camera to create the camera path based on. We'll only be requiring one frame to render, so in this case, I'm just going to select the single frame in the start as a start and end. And then I'm also going to make sure that the platform background NeRF is selected, and I'm going to generate the JSON file. And this JSON file will specify that the camera type will be equirectangular, so we will have an environment map. Once I have my equirectangular render, I can apply this as an environment map by first going into shading, then selecting world over here in this panel, and then creating an environment texture. I also want to create a node for adjusting the position and rotation of the environment texture on the UV map, and to do that, I can select mapping and select texture coordinates. First, I'll drag the generated node into the vector node. Then I'll drag the vector node from mapping into the environment texture. Now we need to select our environment texture. So I'm going to open and select my render. And now I'm going to select the color. And now if I view In the viewport shading, I can change the settings to enable the scene world and scene lights. I can now see my 360 render from the Nerfstudio render in my scene as an environment map. I can also choose to rotate around the environment map if I need to reposition it. This render won't be visible necessarily as a background, although it could be, but the main goal is that if you have any shiny materials, it should be able to reflect off of it. So in our render, we would actually be able to see some part of the sky being rendered on the logo itself. I've created a camera path in the Nerfstudio viewer, and I also want to import it into my Blender scene. Now that I've exported my camera path from the Nerfstudio viewer, I'm now going to import it into my Blender scene as a virtual camera. I can navigate to the Nerfstudio add-on, and over here, I'm going to input my JSON file. Now I click Create Camera from JSON under the Nerfstudio camera generator. Now we can see that I have a newly created camera over here. I'm going to right click it and set it as the active camera. And now as you can see, this has imported the new camera with the exact same animation and frame interpolation speed as the Nerfstudio viewer. You can also use the Nerfstudio add-on in combination with additional features in Blender, such as compositing and using green screen and motion tracking as well. In this portal NeRF composite, I captured 2 NeRFs and created a portal effect in Blender. I used the same camera animation for both NeRFs so that they would have an aligned camera movement for the portal effect. I composited the portal over the first NeRF environment and added a circular mask on that environment to create a window to the second NeRF environment. Compositing these layers created the full portal effect. For this upside down classroom scene, I composited NeRFs over real footage. I used a camera tracking system Tracky, which allowed me to composite Blender objects over real iPhone camera footage. I used this to motion track the NeRFs as I composited them in the scene. The chair and table are NeRF representations in the Blender scene as meshes. I applied rigid bodies to provide a physics simulation for the chair and the table NeRF. I also created RGB and accumulation renders for them, as well as created a mask for the doorway. I turned the classroom NeRF upside down and oriented it properly in the scene in Blender. I also rendered shadows of the meshes of the floating NeRFs off the chair and the table in Blender, and I created a basic outline of the hallway and classroom floor where I placed shadow catchers. I composited this shadow layer over the NeRF of the room and underneath the NeRFs of the floating objects. Compositing all of these together created the illusion of the upside down classroom with floating objects. In total, there are 3 unique NeRFs and a total of 12 video layers in Premiere. For this Lego render, I showed rendering Blender meshes over the NeRF office environment. I rendered a NeRF of the office environment of the table and then layered the renders of the animated Legos from Blender. I applied an environment map off a 360 equirectangular render from Nerfstudio of the office environment to make sure that the reflections of the NeRF environment are visible on the reflections of the Lego pieces. And also you can see that on the table, some of the lighting and shadows is also visible. These are from the Blender renders, which I composited over the NeRF render.